Adventure Build. Tonight's episode, our hero's near demise.
All of this water fell as raindrops or snowflakes. See, it's all going downhill. Since I'm in this boat, I'm going downhill too. It's fascinating when you think about it. We're all moving the same way. Down, down, whoa! Bill Nye the Science Guy.
Bill Nye the Science Guy.
Bill Nye the Science Guy.
Science rules.
Bill Nye the Science Guy.
Inertia is a property of matter.
Bill Nye the Science Guy.
T minus 7 seconds.
Bill Nye the Science Guy.
Brought to you by Sammy's Spawn Hut. Sammy's, located upstream past the big rock left of the old log on the right bank.
Gee, Dad, thanks for taking me camping.
You're welcome, daughter. I feel every young person should experience the great majesty of rivers.
Hey, Dad, who is that guy paddling straight for us?
Well, dear, that's Adventure Bill.
A river is moving water. The water shapes the land it flows through. Take a look at this. These are our big, clear plastic plates of science. Now watch what happens when water flows over them. See, a river starts when it rains someplace, and the water flows downhill. You can see it doesn't flow straight downhill. It breaks up into little rivulets, what we call rills. That's the start of a river. And it always flows downhill because every molecule of water is being pulled down by gravity. Now watch what happens when we make the same kind of flow happen over some sand on top of a plastic plate. Instead of breaking into just one little rivulet, it breaks into one channel. And as more water flows, the wider the channel gets. And rivers choose their course over the land. And you can see that it's taken the sand downhill with it. See, rivers shape the land they flow through. Now, rivers are full of water. Duh. Now, wherever there's water, there are living things. So around rivers, we find special ecosystems we don't find anywhere else. Now, we all need rivers, so... We all need water, so... Rivers are beautiful.
Oh.
Rills. Aren't they? Rills. Woo! Hey, you guys, wait up! Hey, hang on.
Daddy,
I'm coming.
why do they call him Adventure Bill?
Coming up, thrills, chills, and some nasty spills. On Adventure Build.
Today's afternoon movie, Bridge on the River Nye. We'll be back with more of today's movie after this.
You know, rivers and streams always flow downhill. See ya!
We're up in the mountains at the start of a river. Every snowflake that falls here will melt into a tiny drop of water. See this? It's one drop of water. When it falls down, it collects with a zillion other drops into small streams we call rills. The rills flow together to form streams. Streams like this one. They flow over the land till they get here, and it meets this. Millions of liters flowing downhill. It's a river! It's carrying nutrients and tiny living things out here, where it mixes with the ocean. The fresh water mixes with the salt water. And there's whole ecosystems out here that depend on this mixing. It's a process that's been going on for millions of years. Why don't rivers run straight, like a highway? Well, please consider the following. See, rivers are made of water. And water is heavy. Just try picking up a beaker of it sometime. When water gets going in one direction, it tends to stay going in that direction. Just like this car. Watch what happens when it goes off this little ramp. You see how it kept going up for a moment? It didn't just fall right over the end of the ramp. The ramp made the car change direction. The same thing happens with water in a river when it hits rocks or people on skateboards. See? Ooh, this guy should really be wearing a helmet. Ah. He's okay. Now, the water in the river is not only getting pushed by the rock and changing direction, but it's also pushing on the rock a little bit, just like this car pushes on the ramp and nudges it along. So a river is constantly pushing the rocks and soil in it. So the farther downstream we go, the more rocks and soil in the river have gotten pushed downstream. So the river is constantly filling itself in, getting shallower and shallower, more and more spread out. So it's not going as fast, and it doesn't push as hard on the rocks. So the rocks can make it change direction, not just up this way, but sideways. So a river is constantly changing direction, particularly when you get downstream. We say it meanders. Now, an old river has a lot of changes of direction, a lot of meanders. So the more meanders in a river, the older it is. Thank you for joining me on Consider the
When a stream begins to meander, it cuts into its banks, forming meander loops, which gradually erode laterally while flowing downstream. During times of flooding, water covers this nearly horizontal surface. We see Mississippi River meanders in this infrared satellite image. And now, at flood stage, the extensive blue reveals the amount of land that the river claims as its.
Running water, a river, helps shape this gully. But right now, there's no moving water. But judging from the size and greenness of these trees, bet you there will be.
I'm Ben Lomeli. I'm a hydrologist. Hydrologist is a scientist who studies rivers and water in general. This stream is an arroyo. After a good rain, we will see a lot more water in a stream like this. You get flash floods coming through here, and then they recede very quickly, leaving a very dry stream bed again. Here, we can see how they constantly change the landscape. In this part, it's building up on the inside of the bend. On the outside of the bend, there's a lot of power in the water, and it is cutting down the bank. You can see there's quite a bit of sediment in this stream right now. Little bit's okay, it helps upbuild the sandbars, but too much means we got an accelerated erosion problem. There's tremendous contrast between these river ecosystems and the rest of the desert. In these river ecosystems, we see a lot more wildlife, and this vegetation that we see here is very important because it acts much like a sponge. It holds back some of the water in the soil.
Take a look. The hillside is brown, but down by the river, it's green. There's a lot of living things growing there. We find special ecosystems that we don't find anywhere else. That's because that's where the water is. The trees and other plants that are growing around here are soaking up water from the river. They're living things that allow a whole bunch of other living things to be here. It's a whole ecosystem that's supported by the river. Humans are part of river ecosystems too. Human cities and industries usually spring up right around a river. Always have. There's probably a river near where you're living right now. Think about it.
We built 100 cities and 1,000 towns. St. Paul and Minneapolis, Davenport and Keokuk, Moline and Quincy, Cincinnati and St. Louis, Omaha and Kansas City. Across the Rockies and down to Minnesota, 2,500 miles to New Orleans. We built a new continent.
You know, many plants and animals depend on rivers and streams to survive. Hey, I'm stuck. Somebody help me here.
This waterfall was formed by erosion. The power of the water beating against the rock. But the key here is that there are layers of rock. Some are harder than others. Let's go to the chart. As the water flows over the hard surface, it starts to wear it away. Then the water flows over the soft rock. It wears the soft rock away very quickly. So what we end up with is water flowing like this. See? We end up with water flowing over a shelf. It's a waterfall. in the desert floor. And it was made by the Colorado River. And it comes from the word cañón, which is Spanish for tube. So the Colorado River has cut this huge U-shaped tube in the desert. It's huge! It's a tube! It's a Grand Canyon! Beautiful, isn't it? Take a look! It's a dam!
A great barrier to hold water in flood time and to release water down the river for navigation in low water season.
Now, some of the water from the river flows through the dam.
Where there's water for flood control and water for navigation, there's water for power.
That's a lot of dam power. Lot of damn power. Always wanted to say that. Woo! It's a dam right in the middle of a big river, the Columbia River. Now, humans put it there on purpose because we wanted electrical power and we want to be able to control the height of the river so we can irrigate our farms and grow food for ourselves, for us humans to eat. But you put something that big and heavy in the middle of a huge river, you change things. I mean, the ecosystems around here aren't the same as they used to be. Like, if you're a fish swimming upstream and you run into this big dam, well, it's going to change things. I mean, you're going to have to find some way around it or stop right here or something. I mean, it's not going to be like the good old days of being the fish. You know what I'm saying? Now, humans put this thing here for a purpose. But whenever we build something that big in a river, we've got to think about it.
Hey, is that Old Man River?
Hey, how you doing? I'm Old Man River, and I come down here because I like to pee in the river. This river wouldn't even be here if I wasn't in as often as I change the shape of the land. Where the river's churning like this, oxygen gets mixed with the water, and that can be good for fish. But it could also be tough on fish eggs. They can wash away downstream. So fish lay their eggs in shallow pools of gravel. The eggs stick in the cracks and are protected from the flowing water. See, it's just like a bird's egg nest, only it's for fish eggs. So look, you can't be trashing the riverbed. You see, you can't be driving your RV through here and just tearing the place up. It may look like regular old gravel, but it could have fish egg nests in it, for crying out loud. See, no gravel, no nests, no fish. What kind of river is that?
Lots of animals and plants rely on streams and rivers to survive. Unfortunately, there's one animal that can ruin it for all the rest of them. See this old tire? I don't think a fish put this here. Or this piece of plastic? I don't think a bear left this behind. It's us, humans, everyone. When we pollute rivers and streams, we can ruin the entire ecosystem. Like chemicals and sewage and even litter. It all hurts the water. See, a river acts like the neck of a funnel. It concentrates the pollution and then it kills the fish and the plants. So use your head. Don't pollute.
We're on the riverbanks of a river in the middle of a city. And this river, which used to be forested by trees all around us and pretty much well vegetated, has become industrial. A long time ago, before the industry moved in here, the river used to zigzag back and forth across this whole valley. And as soon as the industry came in, as you can see, they straightened out the river and they made it, they dredged up the banks and made the banks straight up and down so they could put the buildings up on top of them. Some people use this river as just a little trash dump. And what we're doing today, which is we're replanting, and as you can see, there's nothing else around here except what we're doing right now.
This instrument measures how low we can plant the plants so that they're not too close to the water.
We're planting these trees out here because we're restoring the environment back to the way it used to be and taking away from the industrialization that's been happening around here.
I feel great that I'm helping out for the community, and I only live 3 blocks away from here, so it's helping out for my community and the community around us.
We're doing our little part to help the world, and that's what counts.
More raging adventures coming up on Adventure Build.
So you don't live near Well, make your own. It's a snack. Start with a mountain where a river comes from. You can build a good one with sand, soil, pebbles, and mud. Maybe something like this. Now, slowly pour a pitcher of water over the top. See how the water finds the quickest way down? It carries the pebbles and dirt with it. It's shaping the land by digging into the soil. It's a river of science.
Since rivers flow downhill, a lot of rivers start on the tops of mountains. Now the water that falls on this side goes this way, and the water that falls on this side goes this way. Let's go to the map. Right here, in the middle of North America, are the Rocky Mountains. The Rocky Mountains divide North America in half, according to their rivers. See, all the rain that falls on this side of the Rockies forms rivers that flow this way, toward the Atlantic Ocean, Gulf of Mexico, or Hudson Bay. All the rain that falls on this side of the Rockies form rivers that flows that way, into the Pacific Ocean. So the Rocky Mountains are what we call a continental divide. They divide a continent. Ha! It's a small idea in a way, but it's a huge amount of water. That was my favorite. Our show. Thanks for watching. You excuse me, I've got some hydraulic transport mechanisms to investigate. I'm gonna drift on out of here. See ya.
Produced in association with the National Science Foundation.
There is an old custom about the divining rod and how it can locate water. A lot of people don't believe that it works, but observe. I swear to you, I did not do that on purpose. It just went there. Unbelievable.
This river is changing the shape of the land. It's wearing away the soft soil, leaving big, hard rocks. Now, as the river flows over and around these rocks, we call it a rapids. So where the water is moving rapidly, we have rapids, see?